In this video, you are going to learn to manipulate the base and height in triangles and quadrilaterals and not get tricked by all the other things on the other sides. So to get us started, let's just take a quick look at these triangles here, and you tell me which ones don't belong. Now, wherever we begin from, the base must be a bottom. You must be able to lay the object flat on that side in order to call it a base. I can twist and turn any shape so that it lays on the bottom, but the height is a little more tricky. Height must always be perfectly perpendicular to the base. Now look at all these triangles. Which one has a height that's not perpendicular? Look at A. The base and the height are perfectly perpendicular. Look at B. The base, if I turn it around in my mind, that height is perfectly perpendicular to it. It looks a little weird when it's sideways, and so that's why you have to imagine turning it. Take a look at C. That height has to extend out away from the base, but that's still a correct base and height. Take a look at D. The base and the height in a right triangle is so easy because the base and the height are both edges. But in A, B, and C, the height's not an edge, but in D it is. So maybe D is the one that doesn't belong. E is just like C because the height is on the outside, and that is perfectly correct for a base and a height. The height could be anywhere, inside or outside. It just has to be perpendicular. The base and the height must be perpendicular to each other. Now take a look at F. The base and the height are perpendicular. So when I ask myself which one doesn't belong, I could say D doesn't belong because it's the only one that has height as an edge. There is another answer here though. I could also say C and E do not belong because they both have height on the outside. It's correct to have height that way, but they're the only ones that are different. Well, there's a lot of correct answers here to which one doesn't belong, and that's kind of left to your interpretation. I want you to make some observations. The thing I need you to know, though, is the formula for a parallelogram and the formula for a triangle. The formula for a parallelogram is that area equals base times height. I don't have to count all the boxes on the inside anymore. I don't have to count the square units. I could just count the base, count the height, and multiply them. In a triangle, I do almost the same thing. I take the base and the height and I divide it by 2. I want you to be using these words when we're talking about it. I want you to say area, base, height, formula, length, side, edge, vertice, or vertex. I want you to use the language of the discipline because I want you speaking correctly so you can understand correctly. If you can use another icon, well then more power to you. Let's warm up with a little true-false, just to kind of get our brains working this morning. First question. A quadrilateral has 4 different angles. Is that true or false? Well, it's sometimes false because some quadrilaterals all have the same angle. We call those squares or rhombuses. But a quadrilateral could have all 4 different angles if it's not a parallelogram or it's not a rhombus or a trapezoid. It's just an irregular quadrilateral. So this one is true and false. All right, I won't trick you on the next one. A triangle has 3 lines. Is that true or false? Only parallelograms can do area equals base times height. That's true. It does not work with trapezoids or irregular quadrilaterals. What about this one? Nope, that's false. Every single triangle could be area is base times height divided by 2. Any triangle on the face of the planet can follow that formula. Every quadrilateral can be area equals base times height. No, that's false. Only parallelograms can. Is that one true or false? True! And that's what this whole video is going to be about, proving that it's true. And that from the observations we made on the last slide is absolutely false. The base must be an edge, but the height does not have to be. The height could be anywhere, anything that's perpendicular. And so sometimes you have to draw your own height. So we're going to be talking about that today. The best way to figure out a height is to know where the vertex is. So here is just a regular old triangle. It is not a right triangle, but it kind of looks almost like one of those angles might be perpendicular. We'll get to that. My first question is, how many vertices or how many vertexes? We don't actually say vertexes, we say vertices. So there's 1, 2, 3. Okay, let's try the other one. How many vertexes? Oh wait, that's not right. How many vertices? Well, that one's easy. 4. What about this one? I count 11. Now here's a very hard one. If I give you a diamond, how many vertices are on that diamond? You're going to have to count the things that are on the back side. So let's see, this corner makes 1, this corner makes 2, this corner makes 3, this one makes 4, 5 down there, 6. I think I missed one, 7. Wait, I think, oh, you know what, forget that one. Let's go back to triangles. Sometimes it's hard to count all the vertices. The point of this one here is I want us to find the height. So the one way that we can find the height to things is find the base and find the vertex that's opposite to that base and draw a straight line down. So first question, where is the vertex that is opposite to the base? Here is the base. Here is the opposite vertex. So I can draw a line between those two that's perpendicular and I'll have my height. There's my height. Okay, let's try that again. Where is the vertex that's opposite to the base? What if I said, this one is the base? Where's the vertex opposite it? Right there. So then my height would connect those two. Where is the vertex that's opposite to the base if the base is right here? Then this one is the opposite vertex. And I draw a straight line from the base to the opposite vertex. And there I have my height. So the base and the opposite vertex can help me draw the height. Just like this. Or just like this. So now I want you to give this a try yourself. I want you to take out a piece of graph paper and you're going to try to draw some triangles. I'm going to describe the triangle, and then you're going to try to draw it. Here we go. Blank graph paper. You could draw a triangle like this. You could draw a triangle like this. I don't care if it's an equilateral triangle. I don't care if it's an acute triangle. It could be a right triangle. It could be an isosceles triangle, or it could even be a scalene triangle. Doesn't matter to me. But I wanted to have a base that's exactly 7 units long, and I wanted to have a height that's exactly 5 units tall. Now mark the vertex of that triangle. Now trace the edges of that triangle, and I want you to pause the video and calculate the area of the triangle you just made. What is the name of the triangle that you just made? Okay, so let's try that again. I want you to draw a base that's 9 units long. I want you to draw a height that's 5 units tall. Mark the vertex of that triangle. Trace the edges of that triangle. And pause the video now and tell me what's the area of that new triangle. What is the name of the triangle you just made? Is it equilateral and acute, or is it a right triangle? But now here's my deeper question. How does that compare to the first one that you drew? Look at the two you drew and think about how they're the same. And here comes your last one. I want you to draw a base of a new triangle, and that base is going to be 20 units long. But the height is only 5 units tall. So it's going to be like kind of wide and kind of short. Mark the vertex of that triangle and trace the edges of it. Pause the video and figure out the area of the triangle that you just drew. What is the name of the triangle now? Is it an obtuse one or is it still acute? Is it right? What kind of triangle is it? And how does that compare to the first triangle that you drew? Now, there's lots of different ways that we can make different triangles, and not all triangles are going to look the same, even if they have the same area. Check this out.
There's a place where the boat leaves from. It takes away all of your big problems. You could worries, you could drop them in the blue ocean, but you gotta get away to where the boat leaves from. Take 1 part sand and 1 part sea, and 1 part shade of a 9 tree, and the drinks set cold and the reggae is hot, and I know this is the place for me.
Now you can see the bases and the height must be straight up and down to each other. They must be perpendicular to each other. And if you can see how everything can be made into a parallelogram or a triangle, you can solve for any area. When you're looking at the base and the height, maybe you're going to call it length, width, depth, height, whatever. As long as you can identify the base and the height, you got the rest of this unit under wraps. You got this.